What if one day we discovered that something out there far beyond the orbit of Neptune was no longer obeying gravity? That's exactly what happened with 3I Atlas. On the 31st of October, 2025, Professor Avi Loeb wrote on his Medium blog, "ALMA data show that 3I Atlas accelerated after perihelion with a clear, non-gravitational motion. If there is no evidence of outgassing, then we are witnessing something that nature can hardly reproduce." You see, when a scientist like Loeb says that, the world listens. Because it means that a piece of the universe, something small, cold, and silent, has just done something our physics can't quite explain. A comet that doesn't behave like a comet. A traveller between the stars that seems, somehow, to be steering itself. He called it the acid test of 3I Atlas, a moment that would decide whether this strange object is a natural wanderer or a sign of something else entirely. And that's when, well, the world fell quiet. Imagine it. Telescopes pointed toward the same patch of sky, data streaming in, and yet the numbers whisper the impossible. A non-gravitational acceleration, as though light itself were pushing it forward. Before we go on, I'd like to ask you to subscribe to the channel and leave a like. My aim here is simple, to help you drift off to sleep while exploring the wonders of science. Where are you on the map? Let me know where you are in the world and what time it is in the comments. It's always fascinating to see who's joining us from all around the world. So, let's continue. It was the morning of October 29th, 2025, when the world turned its gaze toward the Sunday. Somewhere beyond the brilliant glare, 3I Atlas was making its closest approach, its perihelion, the moment it would skim past our star before heading back into the dark. For a few hours, the object vanished, swallowed by the solar light. Telescopes across the Earth, ALMA in Chile, VLT, the great arrays of Hawaii, all fell silent. The data streams flattened into nothing. In that brief interval, our visitor disappeared behind the curtain of the sun, and the universe held its breath. You see, perihelion is like a kind of cosmic heartbeat. Every comet, every icy body that falls toward the sun, pulses with heat and light at that instant. The frozen gases trapped for millions of years awaken and escape into space, producing tails of dust and vapor. It is a predictable, mechanical process, gravity pulling, sunlight heating, gas expanding. But with 3I Atlas, that rhythm was strangely off. When the object re-emerged, a few hours later, something had changed. The first reports came from ALMA, the Atacama Large Millimeter Array, high in the Chilean desert. A subtle shift in position, just a few arcseconds, barely a blink in celestial terms. Yet to astronomers, that small displacement was the sound of something breaking, a mismatch between prediction and reality, between the mathematics of gravity and the movement of matter. It was as if 3I Atlas had quietly decided to step off the invisible path drawn for it by the Sunday. Imagine it. A fragment of rock or metal, perhaps no more than a few dozen meters across, hurtling through space at tens of kilometers per second, then, without warning, drifting ever so slightly faster than it should. No explosion, no visible jet of gas, no plume of dust, just motion quiet, deliberate, and inexplicable. The calculations didn't lie. The trajectory had bent, deviated, ever so faintly, from the perfect ellipse predicted by gravity alone. Scientists don't use words like impossible. They say unexplained. And that's what this was, unexplained. The velocity change corresponded to an acceleration of roughly 0.02 of a millimeter per second squared. It doesn't sound like much, but in the emptiness of interstellar space, such a deviation is enormous. It means a force, something real, measurable was pushing. When the first plots appeared on Loeb's screen, he knew immediately that it wasn't noise. He checked the calibration, the timestamps, the parallax corrections. Everything aligned. The only anomaly was the motion itself. He called it non-gravitational acceleration. It's a phrase that feels dry, academic, but beneath it lies a quiet revolution. If an object is not being moved by gravity, then something else, some other agent, must be at work. ALMA's readings were soon cross-checked with those from the Very Large Telescope. The same conclusion emerged. 3I Atlas was no longer following its expected orbit. The shift wasn't random. It had direction, intent. Part of the acceleration pointed away from the sun, as though the object were repelled by light itself. Another component traced along its path, a tangential boost, as if it were gaining momentum from an invisible wind. And that's the thing. Light has no mass, but it carries momentum. When photons strike a surface, they exert pressure, radiation pressure. Normally, this is minuscule, irrelevant for dense, rocky worlds. But if an object is thin enough, light enough, perhaps shaped like a mirror or a sail, that gentle push could become significant. Loeb began to wonder, could 3I Atlas be something like that? At first, the idea felt audacious, even reckless. Nature doesn't tend to produce large, perfectly flat sheets drifting through space. The forces that shape asteroids and comets are chaotic, sculpted by collisions and ice sublimation, yet the data refused to fit any natural model. There was no spectral evidence of gas release. ALMA saw no signature of water, carbon dioxide, or dust. The object was cold, silent, but accelerating. Meanwhile, in observatories across the world, astronomers watched the sky with growing fascination. Some dismissed the anomaly as an artifact, an error in the data pipeline, a miscalculated reflection, perhaps even a trick of sunlight. Others felt the same chill that had run through Loeb's thoughts, because this wasn't the first time something like this had happened. Years earlier, another interstellar visitor, Oumuamua, had displayed a similar deviation, slight but undeniable. It too had no visible tail, no outgassing, yet it accelerated. History, it seemed, was repeating itself. In science, repetition is everything. When an anomaly happens once, it can be ignored. Twice, and it becomes a pattern. And patterns demand explanation. That evening, as the sun dipped below the horizon in the Atacama Desert, ALMA's dishes turned again toward the coordinates of 3I Atlas. The faint green point had returned, glowing more brightly than before. Spectral analysis revealed an unexpected composition, a dominance of ionized carbon, comise, and C, 2 molecules. These were signatures of excitation, the fingerprints of light interacting with material, but the intensity was too strong for the amount of gas that could possibly be escaping. The brightness exceeded the physics of a normal comet. Perhaps, Loeb thought, this wasn't a body of ice and dust, but a surface, reflective, metallic, catching and scattering sunlight in strange ways. A thin layer of something, shining against the void. He didn't say artificial. Not yet. Scientists rarely begin with the extraordinary. They walk toward it, one cautious step at a time. The more he examined the data, the more he felt that unsettling mixture of awe and disbelief. Because if radiation pressure alone could explain the acceleration, then the object's area-to-mass ratio had to be incredibly high, meaning it was wide and flat, like a sheet, like a sail, a solar sail. Imagine that a fragment drifting between stars, propelled not by engines or jets, but by light itself. It sounds poetic, doesn't it? A ship of sunlight crossing the cosmic ocean. And yet, it might be true. When Loeb published his brief note online, he didn't claim discovery. He posed a question. If there is no evidence of outgassing, he wrote, then we are witnessing something that nature can hardly reproduce. That sentence echoed across the scientific community. Some found it provocative, others thrilling. Many found it unsettling, because to admit that possibility, that something might not be natural, is to step into the unknown. You know, science has always been a dialogue between humility and curiosity. We build equations, and the universe replies sometimes with agreement, sometimes with silence. But every now and then, it whispers back something that changes everything. Perhaps 3I Atlas was whispering now. In the control room at ALMA, the night stretched long and cold. Screens flickered, instruments hummed, and through the thin air of the desert, the signals from space kept arriving, photon by photon. On the display, the faint trajectory trace glowed like a pulse, slightly off, slightly free. It's strange how a few pixels of data can make the human heart race. Because behind those numbers lies the possibility that we are not alone in creation, or that creation itself is far stranger than we've ever dared imagine. By dawn, the preliminary findings were clear. The deviation was real, measurable, and persistent. 3I Atlas was accelerating away from the sun, in a manner no natural mechanism could fully explain. The news spread quietly at first through private messages, late-night calls, whispered debates in university corridors. The tone wasn't triumph, but something else, the kind of hushed wonder that comes when the universe moves ever so slightly beyond reach. A few days later, Loeb would formalize the claim, calling this the acid test of 3I Atlas. If the effect persisted, if no outgassing could be found, then we would be forced to confront a new question. What kind of object can move without the pull of gravity, or the thrust of Symmetry? Gas? The answer might be simple, or it might not. Perhaps 3I Atlas is merely a relic, a shard of some broken world, shaped into a thin sheet by collision. Or perhaps it's something older, something designed. Either way, it is teaching us that the boundary between natural and unnatural is thinner than we once believed. As the object receded from perihelion, its faint light stabilized, but the mystery deepened. The silence between signals became a kind of music, a rhythm of data and doubt. And somewhere in that rhythm, perhaps, the next chapter of our understanding of the cosmos was beginning to unfold. When 3I Atlas emerged from behind the sun, its glow had changed. What had once been a faint, neutral shimmer was now unmistakably alive with color, a cold, vivid green that cut through the black like a whisper of aurora. The telescopes that had waited through the silence of perihelion began to hum again with data, and what they saw left the astronomers both thrilled and uneasy. The object was now radiating a spectrum characteristic of ionized carbon, CO- and C, two molecules, the same kind of luminescence one might see from an ordinary comet, but the brightness was all wrong. It was too strong, too pure, far beyond what the measured amount of gas could possibly produce. You see, a comet's glow is a conversation between sunlight and gas. The sun's radiation strips electrons from molecules, creating ions that shine in specific colors. The green of CO- is a telltale sign that the comet's surface is venting carbon compounds into space. But 3I Atlas was quiet. There were no plumes, no jets, no visible tails. The light was there, but the source was not. It glowed like a comet and yet behaved like a stone. That contradiction became the puzzle and, perhaps, the poetry of this object. At the observatories in Chile, scientists stared at their spectral graphs. The emission lines were sharp, unambiguous, dancing in perfect alignment with the signature of CO-maze. But the absence of any trace of water vapor or carbon dioxide was baffling. A comet this active should have been leaking its insides into space. Yet here was something cold, dense, and sealed, somehow glowing without releasing anything. It was as if the object was borrowing light, amplifying it, and giving it back. In the hours that followed, speculation bloomed like wildfire. Some thought the green hue was the result of ionized carbon coating the surface, reflecting sunlight differently as it passed through thin layers of material. Others suspected a layer of dust grains acting like a photonic resonator, scattering light in narrow bands. But the intensity was too great to fit any of those models. Whatever was happening, it was happening in a way nature had not shown us before. And that's the thing about astronomy, it reminds us that most of the universe is made of questions disguised as light. Each photon carries a message, but it speaks in riddles. The glow of 3I Atlas was one such riddle. Professor Loeb was cautious. He refused to use words like artificial or engineered. Instead, he described the light as non-linear, meaning that its intensity did not match the expected energy output from natural excitation. He compared it to a mirror tilted toward the sun, amplifying certain wavelengths, suppressing others. If that were true, then the green light wasn't merely emitted, it was sculpted. For weeks, data from ALMA, VLT, and smaller observatories began to converge. The spectral pattern was stable and persistent, no fading, no fluctuations from rotational effects. It was as though 3I Atlas were presenting one face to the sun, keeping the same orientation as it moved. That detail caught Loeb's attention. Most comets spin, their brightness rises and falls as they tumble. But not this one. It glided smoothly, like a compass needle locked to the light. And that, perhaps, is what disturbed everyone the most. The stillness. For an object traveling at tens of kilometers per second, 3I Atlas seemed too deliberate. Each photon that struck its surface reflected in a way that suggested order, symmetry. It wasn't just wandering through the solar system. It was moving with purpose, though no one could say whose. Astronomers began revisiting old data from earlier in its trajectory, back when it was still inbound toward the Sunday. The color profile back then had been neutral, almost dull, a featureless grey, like a fragment of rock or metal. Only after perihelion did the color shift, as if the encounter with sunlight had awakened something dormant on its surface. Some proposed a chemical explanation, sublimation of trapped carbon compounds releasing a transient glow, but the numbers refused to agree. The object would need to lose a measurable mass of material to achieve that brightness, and yet its light curve remained constant. No fading, no mass loss, no tail. Well, you see, that's what makes the cosmos endlessly humbling. When an object violates one law, it doesn't break physics, it invites us to expand it. Perhaps light itself was the clue. In the emptiness of space, photons are not just illumination, they are force, energy, pressure. A perfectly reflective surface could use that pressure as propulsion, a concept we call radiation sailing. If 3I Atlas had a reflective surface, even a partial one, then its change in color might not be chemical at all, but mechanical. A visible hint that sunlight was now doing more than lighting it, it was pushing it. Imagine that, a fragment of matter, thin as foil, vast as a city block, gliding silently on a beam of light. No engines, no fuel, just the steady push of photons over millions of kilometers. It sounds like something from a dream, and yet the equations say it's possible. But, of course, the simplest explanation is not always the truth. Many in the community remain skeptical. A group from the European Southern Observatory suggested that the green emission might be a resonance effect from microscopic crystals in the material, a photonic lattice, perhaps, acting like a filter for sunlight. Another team in Japan proposed that the light could be an illusion caused by phase scattering, where particles near the surface reflect sunlight toward the observer at just the right angle to exaggerate specific wavelengths. The debate spread across journals, social media, and late-night calls between research teams. Still, none of those explanations could account for the acceleration measured days earlier. The motion and the light, two mysteries, now entwined. One spoke of movement without thrust, the other of brightness without fuel. If the same mechanism caused both, then whatever was happening on that tiny world was deeper than chemistry. I suppose, in moments like this, science begins to sound like philosophy. Because when you strip away the data, what's left are questions about intention. Why does it shine this way? Why now? Why only after passing the sun? Perhaps it was nothing more than a fragment reacting to heat. Or perhaps, as Loeb hinted, it was a test, an experiment conducted not by us, but by nature, or something that once understood nature far better than we do. Night after night, telescopes continued to track its glow. The color persisted, unwavering, like a heartbeat echoing through space. There was a strange beauty in its defiance, a light that refused to fade, a signal that refused to explain itself. And that's what drew people in. Beyond the technical papers and spectral charts, there was a growing sense of wonder, of unease, of longing. We wanted it to mean something, because that's what we humans do when confronted by mystery. We turn it into story. We imagine the green light as a message, a sign, a mirror. We wonder if perhaps, somewhere long ago, someone or something had launched it, or maybe it was nature reminding us that her imagination is far greater than ours. By mid-November, the data archive was overflowing. The green intensity curve held steady. The spectral lines showed no drift. The absence of gas emissions became, ironically, the most powerful evidence of all. Whatever was making 3I Atlas glow, it was not outgassing. It was not combustion. It was not dust. It was, simply, light interacting with a surface that seemed to invite it. Loeb's latest note to colleagues was brief. If this brightness is due to reflection, he wrote, then the geometry of the object must be highly constrained, possibly flat, possibly thin. In any case, unnatural in shape. Those words, though cautiously phrased, rippled through the community. Unnatural. Not artificial, not alien, just not ordinary. And in science, That's sometimes the most dangerous word of all. Outside the observatories, the world had begun to notice too. Newspapers spoke of the green visitor. Children drew pictures of Televi, a glowing leaf sailing past the Sunday. The public saw beauty, where scientists saw contradiction, but perhaps those two things were never so different. Because in truth, what moved everyone was not fear but fascination, the feeling that the cosmos was speaking again, in a language we only half understood. And somewhere, far beyond our planet, 3I Atlas kept gliding, its emerald light shimmering against the black. It was still accelerating slightly, still defying the curves that gravity had written for it. And every photon it reflected carried not just energy, but mystery, a mystery that was about to deepen as the numbers began to reveal something even stranger about its motion, something that would push the debate beyond chemistry, beyond reflection, into the realm of pure physics. As the glow of 3I Atlas continued to drift across the night sky, the numbers began to whisper something extraordinary. The light was mesmerizing, yes, but it was the motion, quiet and relentless, that kept the scientists awake. The trajectory, once smooth and obedient, was beginning to deviate, not by much, only by fractions of a degree, but enough that the mathematics no longer held. Every night, as new data came in, the small green wanderer appeared slightly farther from where it should have been. Gravity alone could not explain it. The object was accelerating. The word itself carries weight acceleration. It implies intention, momentum, direction. For a celestial body, that should mean a physical force at play, jets of vapor, a burst of gas, an unseen companion tugging gently at its path. But there was nothing. No tail, no dust, no faint whisper of water vapor in the spectrum. The universe was utterly silent, and yet something out there was moving faster than it should. When Loeb first plotted the curve, the deviation appeared almost poetic in its precision. A steady increase, subtle but consistent, amounting to roughly 0.02 millimeters per second squared. In human terms, it's the speed of a drifting hair in still air, but in cosmic terms, stretched over millions of kilometers, it was staggering. That tiny push was enough to alter the orbit entirely, to pull 3I Atlas off the invisible path carved by the sun's gravity. You see, that's what makes physics both beautiful and unforgiving. It has no patience for mystery. Every movement demands an explanation. And yet here was a movement that defied all known forces. The acceleration seemed to have two distinct components, one directly away from the sun, as though light itself were repelling it, and another along its path, propelling it forward through space. It wasn't just drifting, it was gliding, as though surfing an unseen current of energy. The analysts at the Minor Planet Center ran simulations day and night, adjusting for solar wind, for radiation drag, even for hypothetical jets of frozen gas emerging from beneath the surface. Nothing fit. The acceleration was too stable, too uniform. Jets of vapor would flicker, fluctuate as the object rotated. This was different. It was continuous, unwavering, deliberate. The math refused to bend, and so the questions began to multiply. Loeb compared the new data against models from other observatories, and every comparison told the same story. 3I Atlas was no longer a passive traveler. It was, in some sense, active. The term he used was non-gravitational acceleration, a phrase that sounds sterile but conceals a quiet astonishment. Because to say that something in the cosmos is accelerating without gravity or thrust is to say, in essence, that it's doing something on its own. At first, many dismissed it. Data noise, one astronomer said. An instrumental offset, another claimed. But the numbers were unyielding. Independent teams in Chile, Spain, and Japan all found the same pattern. The deviation wasn't an illusion, it was a fact. 3. Atlas was experiencing a force unaccounted for by any known, natural process. The press caught wind of it soon after. Headlines spoke of a runaway interstellar object, a cosmic anomaly defying gravity. Some reached further, whispering words like probe or artifact, though the scientists themselves avoided such language. They preferred precision to poetry, but in truth, even precision couldn't cage what they were seeing. The object was acting as though it had a will. And that's the thing about discovery, it always begins with discomfort. The numbers don't fit, the models break, and for a brief moment, you feel the edge of the unknown pressing back. For Loeb, that edge had arrived again, just as it had years ago, with Oumuamua, the same improbable acceleration, the same silence from the void. History, it seemed, had a rhythm of repetition, and perhaps the universe was composing a melody through these anomalies. He wrote in his notes, "If the acceleration is real and not caused by outgassing, we are witnessing an entirely new class of interstellar phenomena." Then, a pause, a hesitation before adding, "or something that imitates the natural while being anything but." It was not a claim, but a whisper of possibility. Meanwhile, the community divided. Some clung to traditional explanations, perhaps a fragment of volatile ice beneath the surface, sublimating just enough to nudge the orbit. Others, including a younger generation of astrophysicists, raised on open data and bold ideas, began to entertain more radical possibilities. Could radiation pressure, the gentle push of light, be enough to explain it? If that were true, then 3I Atlas had to be unusually light, perhaps hollow, or broad, and thin like a sail. A solar sail, they called it, a sheet of material so reflective that photons could impart measurable acceleration. It was an idea once confined to science fiction, now resurrected by data that refused to behave. But there was a problem. For radiation pressure alone to account for the observed force, the object's surface area would have to be enormous relative to its mass. No natural fragment of rock or ice could meet that ratio. The numbers pointed towards something else, an engineered geometry, or an impossibly delicate structure formed by processes we had never witnessed. Either way, nature was stretching her imagination to the limit. Loeb, ever careful, suggested a simpler hypothesis. Perhaps the object was composed of an unusually porous material, something like a cosmic aerogel, so light that sunlight could nudge it along. Yet, the absence of gas or dust emission undermined that idea. The structure seemed solid, consistent, and remarkably stable. There were no signs of tumbling or rotational wobble. It moved like a balanced craft, keeping its orientation steady as it journeyed outward. Observatories across the world kept their eyes on it. Data from ALMA confirmed the acceleration vectors, while the European Space Agency verified the positional drift. Even NASA's Deep Space Network began listening, just in case the object was emitting radio signals. It wasn't, of course. There was only silence. But that silence, somehow, made it all the more haunting. You know, the universe rarely shouts. It whispers, in deviations and delays, in millimeters per second squared. Those tiny anomalies are the fingerprints of the unknown. Every great leap in science has begun with one of them, from Mercury's precession that led to Einstein's relativity, to the faint hiss of the cosmic microwave background that revealed the birth of the universe. Perhaps this was another whisper like that. Still, skepticism is the pulse of science. Without it, we would be lost in our own imagination. Some researchers urged caution, reminding everyone that even the smallest systematic error, a misaligned telescope, a calibration drift, could produce apparent accelerations. The debate grew heated, but underneath the arguments lay a quiet awe, because, even if it turned out to be an error, the very possibility had opened a window into something profound, the fragility of our certainty. Night after night, Loeb returned to the data, recalculating, rechecking, trying to find comfort in the numbers, but the pattern remained. The acceleration vector pointed not just away from the Sun, but slightly along the orbital path, about 60 kilometers per day, squared in tangential acceleration, 135 kilometers per day squared radially. The alignment was too clean to be coincidence. And as 3I Atlas continued its journey outward, its green light steady, the equations began to reveal something deeper. If this non-gravitational acceleration persisted, then our very model of celestial mechanics might require revision. The assumptions we make that all motion is governed by gravity alone would no longer be universal. It would mean that other forces, subtle and unrecognized, might be sculpting the paths of interstellar objects. Perhaps, Loeb mused, we've mistaken simplicity for truth. Perhaps the universe has always been more playful than our equations allow. Because if light, the gentlest thing in existence, can move mountains of rock across the heavens, then maybe gravity is not the whole story, only the first chapter. By late November, the community had settled into a rhythm of fascination and restraint. Papers were drafted, counter-arguments prepared, telescopes recalibrated for further tracking. Every dataset seemed to confirm the same improbable acceleration. Some researchers proposed that the effect might come from a previously unknown property of interstellar dust interacting with solar radiation, a kind of photonic drag that could mimic propulsion. Others went further, suggesting that 3I Atlas might belong to a class of interstellar debris, thin sheets ejected from dying stars, remnants of ancient collisions or stellar winds. Each explanation tried to restore order, to pull the phenomenon back into the comfortable embrace of physics. But deep down, everyone knew the truth. The numbers still didn't fit, and so the mystery deepened. The green light continued to shimmer, the object continued to glide, and human curiosity, once again, found itself suspended between wonder and disbelief. Perhaps, Loeb thought, this wasn't merely a question of motion, but of meaning, because if a small interstellar traveler could ignore gravity's script, even slightly, what else might be possible? What other laws of the universe might we have mistaken for absolutes? The night sky, once quiet, now felt alive with questions. Somewhere out there, beyond the edge of the solar system, 3I Atlas was still accelerating slowly, steadily, impossibly pulling not just itself, but our understanding of nature into uncharted space. And as the next round of observations began, astronomers prepared to look deeper still, searching for traces of gas, vapor, or anything that could explain what was about to come. For weeks after the discovery of its strange acceleration, 3I Atlas remained under relentless observation. Each new night brought a little more data, a few more numbers that only deepened the mystery. Astronomers turned their instruments toward the faint emerald light, dissecting it for answers, searching for the one signal that could restore order to their models, the telltale trace of gas escaping into space. But none came. The object was cold, dark, and eerily still. If it were a comet, it should have been alive with motion. Heat from the sun should have boiled the frozen gases beneath its crust, releasing jets of water vapor and carbon dioxide that burst outward like invisible engines. Every comet we have ever known behaves this way. It is a predictable choreography of heat and release, gravity and drift. Yet 3I Atlas refused to dance to that rhythm. There were no signs of jets, no flickering plumes in the spectrum. ALMA's detectors, sensitive enough to pick up even the faintest whisper of sublimating ice, saw nothing. No CO2, no H2O, no silicate dust. Just the smooth, quiet reflection of a body untouched by internal activity. Loeb wrote about it plainly, almost with restraint. If there were outgassing, he said, Alma would have seen the spectral lines. But the spectral lines were clean, unbroken, featureless. A flat silence where the signature of gas should have been. It was as though nature itself had chosen to withhold the explanation. You see, in science, absence is sometimes more revealing than presence. The lack of gas was a statement, a defiance of the most basic laws governing cometary physics. Without gas release, there could be no reactive thrust, no non-gravitational acceleration. And yet the acceleration was real, measured, confirmed. The contradiction stood like a monument in the data. At first, some teams proposed that the object might be covered in a layer of refractory material, rock, or carbonized dust that sealed away the ices beneath. That could, in theory, hide any gaseous escape from our view. But if that were true, then 3I Atlas should not have brightened at all. Its surface would have remained inert, dark, and dull. Instead, it shone vividly, bathing the detectors in spectral green, its intensity unwavering. It was as though the light were coming not from within, but from its very skin, reflected, refracted, perhaps even manipulated by the structure of its surface. A few skeptics clung to the possibility of instrumental error. Could the readings have been too clean? Could some calibration drift have erased the spectral lines of water or carbon dioxide? Alma's engineers checked. The data were impeccable. Every pixel, every calibration, step held. The silence of the spectrum was not a mistake. It was a message, and that message was unsettling. Because if it was not outgassing, then the acceleration must have another cause. Imagine, for a moment, a fragment of interstellar matter, cold as the void, solid as iron, gliding through space without burning, venting, or disintegrating. Every law of thermodynamics says it should have responded to the sun's heat, to the pull of its gravity. But instead, it slipped through like a ghost, changing course without resistance, without force that we could see. Loeb and his team ran the models again. They simulated sublimation from every possible volatile compound water: carbon monoxide, ammonia, methane. None could produce the observed acceleration without leaving a spectral fingerprint. Even exotic ices, like those found in the outer Kuiper belt, would have left some sign. But there was nothing. 3I Atlas was clean, perhaps too clean. That's when a new hypothesis began to take shape, fragile and daring. What if the acceleration was not due to internal activity at all, but external interaction? Something about the object's shape or composition that allowed it to respond differently to light? Loeb hesitated to use the word, but others whispered it freely: reflection. Light, after all, carries momentum. It can push, however faintly, against matter. We know this as radiation pressure, a gentle force that can, over time, nudge even massive objects off their predicted paths. But for that force to produce an acceleration as large as the one seen in 3I Atlas, the object would need to be unusually lightweight and thin, something that could catch sunlight like a sail. And yet, how could nature produce such a form? A comet, by definition, is an irregular lump of ice and dust, battered by collisions and cosmic weather. Nothing in our solar system, nothing we've ever observed, takes the shape of a wide, flat sheet. That is the realm of engineering, not geology. Still, Loeb refused to leap to conclusions. He reminded his colleagues that science is not a declaration, but a dialogue. If not gas, he wrote, then what? We must let the data speak, before imagination takes over. But imagination was already speaking. Some saw in the smoothness of the spectra, in the precision of the acceleration, a design too clean to be random. Others sought subtler natural explanations, perhaps an ancient fragment of a tidally disrupted world, stretched into a thin layer by stellar forces. There were even murmurs about crystalline carbon, a mirror-like shard born from the death of a distant star. The possibilities multiplied, each one more improbable than the last. Meanwhile, the object continued its silent flight. Instruments from the European Space Agency and NASA's infrared networks scanned for any thermal emission that could betray hidden activity. Nothing. The object remained as cold as interstellar dust, its temperature stable, unresponsive, even to the sun's warmth. It absorbed nothing, emitted nothing. It simply reflected. You know, there's something almost human in our relationship with anomalies like this. We want to understand, to fold the unfamiliar back into our patterns of logic. But sometimes the universe refuses to cooperate. It leaves us standing beneath the stars, holding a set of rules that no longer seem complete. In quiet moments, Loeb would look at the plots on his screen, those smooth, unwavering lines, and feel a strange blend of awe and humility. Science thrives on doubt, and doubt is precisely what 3I Atlas had given in abundance. He recalled how, a century earlier, the orbit of Mercury had refused to fit Newton's equations. The discrepancy was tiny, almost laughable, and yet it became the seed from which Einstein's general relativity would grow. Perhaps, he thought, 3I Atlas was another seed, one that might someday make us rewrite our understanding of motion itself. If not gas, then what? That question became the pulse of the debate. Researchers from Tokyo to Paris offered alternative hypotheses, each more speculative than the last. Some suggested magnetic interactions, others cosmic dust drag, even the pressure of solar wind particles reflecting off a charged surface. But none of them worked. None matched both the direction and magnitude of the acceleration. And the more they failed, the more the object's quiet defiance seemed to grow. By December, the mystery had turned philosophical. The journals were full of papers that read less like research and more like meditations on what it means for a force to exist unseen. A cold, solid object, moving as if propelled by something we could not name it, was both terrifying and beautiful. Perhaps, Loeb mused, the object was not breaking the laws of nature at all, but revealing a corner of them we had not yet illuminated. That thought comforted him. Because, in the end, Science is not about certainty. It's about the willingness to stay with uncertainty long enough for it to become knowledge. The absence of gas had now become a presence, a symbol of what we do not yet grasp. 3. Atlas was teaching humanity something profound, that sometimes the quietest things in the universe speak the loudest. And as the object drifted further from the sun, its acceleration steady, its glow unwavering, the idea began to take hold among theorists and dreamers alike. If light can move it, then light must be the key. If photons can push a world, then perhaps, in the thinness of its surface, we might find the truth. And so, the discussion turned gently, inevitably, toward the strange possibility that light itself was no longer just illumination, but a force, a hand shaping the motion of matter. It was the beginning of a new conversation, one that would blur the boundary between reflection and propulsion, between nature and design, and lead directly to the next great idea. Perhaps it began, as all revelations do, with a simple question, one that feels obvious in hindsight. If not gas, if not internal pressure or magnetism, then what was left to move 3I Atlas? The answer, as it turned out, had been there all along, streaming endlessly from the sun, touching every atom and every surface in the solar system, light itself. Light, you see, has no mass. It has no substance in the way we understand matter. And yet, it carries momentum, a whisper of motion woven into every photon. When that photon strikes something reflective, it imparts a tiny push, an almost imperceptible pressure. We call it radiation pressure, a force so delicate that it can be ignored for planets and moons, but not for something as light, as eerily thin as 3I Atlas seemed to be. Brian Cox, in one of his lectures, once described light as the painter of motion. It doesn't just reveal the world, it shapes it. And perhaps that's exactly what was happening here. The sun's light was not simply illuminating this interstellar traveler, it was steering it. At first, it sounded fanciful. Even Loeb, who had grown accustomed to walking along the boundary between science and imagination, hesitated. But the math was persuasive. If the object had a high area-to-mass ratio, in other words, if it was large and thin, like a mirror or a sheet of metal foil, then the sun's radiation alone could produce the precise acceleration measured after perihelion. The numbers matched perfectly, almost suspiciously so. Imagine it. Sunlight, traveling across millions of kilometers, striking a fragile, silvery surface, drifting in interstellar space. Each photon reflects, each reflection imparts a tiny nudge. Billions of nudges together form a force, subtle but steady. Over days, weeks, months, that force becomes motion. The object begins to accelerate not because of engines or explosions, but because of light itself. It's a beautiful thought, isn't it? The idea that light, the very thing that lets us see the cosmos, might also be its quiet architect. The same sunlight that warms our skin, that feeds the earth, could, in the emptiness between stars, become a sail. The term that appeared in the scientific papers was solar sail. It sounds poetic, almost romantic, but the physics behind it is simple. A solar sail is a thin, reflective surface that uses radiation pressure to propel itself through space. The concept had long been proposed as a method for interstellar travel. Engineers and dreamers had imagined building enormous sheets of film, kilometers across, that could ride beams of light to the stars. But to see one, to actually observe an object behaving like one, was something else entirely. Could 3I Atlas be such a thing? Loeb posed the question carefully, aware of how provocative it would sound. In his note, he wrote, "If an object with the observed acceleration has no signs of outgassing, then radiation pressure must be considered. This requires a thickness on the order of a fraction of a millimeter, assuming ordinary material density. In other words, impossibly thin for any natural formation." The statement reverberated across the astrophysics community. Some dismissed it outright. Nature, they said, doesn't make mirrors. Others paused, caught by the elegance of the idea. Because the truth is, the universe often surprises us by doing things we thought only intelligence could. You know, perhaps that's the beauty of science. It doesn't demand belief, only curiosity. Whether 3I Atlas was a fragment of natural perfection or something crafted by hands unknown, it was still obeying the laws of physics. The question was not whether it could happen, but how. To understand this better, imagine a grain of dust in sunlight. Each photon that hits it imparts a small force, nudging it away from the sunday. Over time, this is why dust tends to clear from the inner solar system, blown outward like cosmic pollen. Now, expand that principle by a factor of 1,000,000,000,000, not dust, but a reflective plane, the size of a ship, responding to every photon. The push becomes measurable, visible, in the drift of its orbit. That was what Loeb's equations suggested. If this interpretation were true, it would explain everything: the steady acceleration, the lack of gas emission, the stability of the object's orientation. It would mean that 3I Atlas wasn't reacting to the sun, it was harnessing it. And yet, this explanation opened more questions than it answered. If radiation pressure was indeed the cause, then the object's surface had to be engineered with extraordinary precision. A natural body, no matter how eroded or stretched, would scatter light irregularly. 3I Atlas, by contrast, reflected consistently, smoothly. Its trajectory was remarkably stable, with no signs of tumbling or chaotic spin. It was as if the object knew where its center of balance lay. That observation unsettled even the most cautious researchers. To remain stable under radiation pressure, a sail must align itself correctly, with its reflective plane angled to maintain equilibrium. It's a dance between light and geometry, one that requires a delicate balance. Yet 3I Atlas seemed to perform that dance effortlessly, without any visible rotation. Some theorists began to wonder if this stability was a coincidence or a clue. Perhaps, they said, the object's shape, its thinness, its reflectivity was not accidental. Perhaps it was a relic of some natural process we had never witnessed before. But others, quietly, began to whisper the possibility that it might be something older, something crafted long ago and set adrift in interstellar space. You can feel, can't you, the unease that idea brings, the notion that we might be looking at a message or a mechanism from another intelligence. Not a living ship, not a signal, just a silent artifact, moving through the void according to the same physical laws that govern everything else. It doesn't need to announce itself. Its very existence, its motion, would be enough to make us question what is natural and what is not. Loeb resisted sensationalism. He spoke instead of wonder, of humility, before the data. If it is a solar sail, he wrote, then it proves such things can exist, whether built or born. That was his genius, to leave the door open, to allow nature and possibility to share the same room. And perhaps that's the real significance of this discovery. Not whether it's natural or artificial, but what it reveals about the universe's capacity for complexity. Light, it seems, is not merely a messenger of the stars. It is a sculptor, capable of shaping motion and meaning alike. The realization inspired a strange kind of poetry among scientists. Late-night conversations at observatories turned philosophical. Some spoke of light as a language, one the cosmos has always used, but which we are only beginning to understand. Others spoke of entropy, of order emerging from chaos, of how radiation pressure could turn random fragments into cosmic sails without intention, only physics. Meanwhile, 3I Atlas continued to glide outward, away from the sun, carrying its mystery with it. The data showed that the acceleration remained constant, its direction precisely aligned with solar radiation. The match was too perfect to ignore. It was light, the oldest force in the universe, older even than gravity doing the work. And that's the thing about discovery. The more we understand, the more we are reminded of how little we truly know. Light, this simplest of phenomena, was now revealing itself as an architect of motion, a silent navigator across the interstellar sea. If 3I Atlas truly was propelled by sunlight, then perhaps it wasn't unique. Perhaps countless such objects drift between the stars, sheets of dust, relics of long-dead systems, or fragments of something we've yet to imagine. The thought is humbling. We are surrounded by ancient travelers, and only now are we learning to listen to the stories they tell through their motion. As the debate deepened, Loeb posed a final question to his students. If nature can build a mirror, what else can she build? The room was quiet. It wasn't a challenge, but an invitation, a reminder that science, at its heart, is an act of curiosity rather than conclusion. And so, The world watched as three Atlas drifted onward, propelled by the faintest of forces, each photon a breath of movement against the canvas of space. Its acceleration, once mysterious, was now the embodiment of elegance, proof that even in silence, the universe speaks through light. But with that understanding came a new uncertainty. If radiation pressure could explain its motion, then it raised the next inevitable question: what exactly was reflecting that light? What kind of surface could endure such travel, across such distances, without crumbling to dust? The answer, whatever it was, would lead them beyond physics into the delicate boundary between nature and design, a place where skepticism and wonder share the same sky. There's a peculiar stillness that follows great discoveries, a silence made not of peace but of hesitation. After the notion of the solar sail took root, the scientific world entered such a silence, a quiet filled with disbelief, wonder, and something close to fear. Because if the acceleration of 3I Atlas was truly caused by radiation pressure, then the object before them was no ordinary rock from the depths of space. It was something that had no clear category, a boundary case between what nature could produce and what only intelligence could conceive. At first, the idea seemed too bold, even reckless. Scientists are trained to be cautious, to walk only as far as the data allows. And the data, though consistent, was thin, a few spectral lines, a steady curve of acceleration, a glow too clean to be chemical. It wasn't proof, it was invitation. An invitation to think differently, to question where the edge of nature really lies. Loeb, in his calm, deliberate way, never claimed certainty. He simply asked, if not natural, then what? It was a question that sounded simple but carried the weight of centuries of scientific tradition. The natural world has always been vast enough to hold our ignorance. Comets that glow, pulsars that sing, black holes that swallow light. And yet, this question, this quiet, then what, unsettled everyone who read it. You see, science isn't built to handle miracles. It's built to chase them, to dismantle them, to find the mechanism behind their beauty. But every once in a while, something appears that blurs the boundary between the explainable and the imagined. That's what 3I Atlas became, a mirror reflecting both our understanding and our limits. In university lecture halls and observatories, debates broke out that sounded more like philosophy than physics. Could a natural process, somewhere in the cold machinery of the cosmos, produce something so thin, so geometrically precise, that light alone could move it? Some said yes, perhaps collisions in the atmospheres of dying stars might flatten fragments into sheets. Others argued no, that nature, left to its chaos, produces curves, not planes, randomness, not symmetry. One young researcher compared 3I Atlas to the blades of metallic crystals that form under rapid cooling. Maybe it's a relic, she said, a shard from a stellar explosion, preserved for eons, drifting through interstellar space until it found our Sunday. It was a beautiful idea, poetic, almost romantic, but it didn't quite fit the numbers. The density required was too low, the reflectivity too perfect. And so, slowly, uncomfortably, the conversations began to drift toward the unspoken possibility. What if it wasn't made by nature at all? What if it was made? The moment that thought is spoken, everything changes. Because to admit it, even as a hypothesis that something artificial, built by an unknown intelligence, might be drifting through our solar system, is to stretch the definition of science itself. It doesn't mean belief in aliens or spaceships or science fiction. It means acknowledging that intelligence, somewhere, could have left a trace in the cosmic debris. And 3I Atlas, shimmering silently in its emerald glow, fit that description with unnerving grace. Still, the community resisted. Some rejected the notion outright, calling it premature, even irresponsible. Others, though they wouldn't say it aloud, found a thrill in the possibility. Because what if? Just what if the universe was speaking, not through light or gravity, but through design? Perhaps the distinction between natural and artificial isn't as clear as we think. After all, what is technology, if not nature expressing itself through intelligence? A solar sail, whether formed by accident or intention, obeys the same laws of physics. It is still light, pushing on matter, momentum transferred photon by photon. The difference lies not in the motion, but in the meaning we assign to it. I suppose that's the fragile beauty of this moment. Science and imagination are standing face to face, and neither can quite look away. Brian Cox once said that every great discovery begins with a crack, a small deviation between what we expect and what we see. The history of science, he said, is the history of those cracks becoming doors. 3. Atlas, with its impossible acceleration, was one of those cracks. It didn't destroy our understanding, it expanded it. And yet, the questions lingered. If this was a natural object, then we had just witnessed one of the most extraordinary coincidences in astrophysics, a fragment shaped perfectly for solar propulsion, stable over astronomical timescales. But if it wasn't, then it was something far more profound, evidence that somewhere out there, beyond our little sphere of light, another intelligence had once existed. The prospect unsettled many, not because it was impossible, but because it was too vast. It meant that our place in the cosmos, the fragile illusion of being alone, might no longer hold. To look at 3I Atlas was to see ourselves from the outside, to realize that intelligence, once born, might not be unique. In interviews, Loeb was careful. Extraordinary claims, he said, require extraordinary evidence, but we must not be afraid to follow where the evidence leads. It wasn't a declaration, it was a reminder. Science isn't about comfort. It's about curiosity strong enough to walk into the dark. The media, of course, ran with the most dramatic version. Headlines spoke of alien sails and cosmic messengers. But in the quiet corners of the scientific world, something gentler was happening. The boundary between nature and technology was being re-examined, redrawn. Perhaps the two were not opposites at all, but part of a continuum one, flowing inevitably into the other. After all, what we call technology is, in essence, nature organized by thought. A solar sail built by an intelligent species is no less an expression of the universe than a star or a nebula. Both are born of physics, both obey the same equations. The difference lies in the intention behind their creation. And if 3I Atlas truly was an artifact, then it was still, in a sense, natural an extension of cosmic evolution, shaped by minds that once wondered, perhaps, as we do now. That idea, strange as it seemed, brought comfort to some, because it meant that intelligence wasn't a cosmic accident, but part of a larger story, one written in light and gravity, in the drift of dust and the motion of stars. But skepticism persisted, as it should. For every voice that whispered artifact, another insisted on patience. "We have not yet exhausted natural explanations," said one astronomer from the European Space Agency. The absence of evidence is not evidence of intention. It was a good reminder. The universe is vast, and humility is the price of understanding it. And so, the debate became a kind of mirror, reflecting the tension at the heart of science itself, the need to question, to dream, to doubt. Perhaps that's why 3I Atlas mattered so much. It wasn't about proving or disproving alien technology. It was about learning how to stay suspended between certainty and wonder without collapsing into either. As the weeks passed, the object continued its steady outward glide. It was growing fainter now, drifting farther from the sun, beyond the reach of most ground-based telescopes. But in its fading light, something had shifted in us. The conversation had moved from, "What is it?" to, "What does it mean?" And maybe that's the real boundary, not between nature and technology, but between knowledge and meaning, between what we can measure and what we can only feel. Because when you look at an object like 3I Atlas, gliding silently across the cosmic sea, you can't help but sense that it's telling a story not just about physics, but about possibility. Somewhere in the dimness of the Atacama night, Loeb wrote another line in his notebook. "In science, bold ideas begin as small errors. Perhaps 3I Atlas is the universe's way of inviting us to make one, and that's the thing. The greatest discoveries are never about certainty. They are about the courage to wonder, to linger at the edge of understanding, where the next chapter is already waiting to be written, the chapter where physics itself will have to decide whether gravity is still the only storyteller in the sky." It was sometime in early December, the air cold and thin in the Atacama Desert, when a realization began to take hold among those studying 3I Atlas. The conversations that had started as speculation were now turning towards something deeper, something structural. Because if the object truly was accelerating under a force that could not be explained by gas or gravity, then the implications stretched far beyond the object itself. It meant the foundations of celestial mechanics, the equations that had guided spacecraft, predicted planetary motion, and defined our understanding of the cosmos, might not be complete. For centuries, we've trusted that gravity is the great architect of motion. Every orbit, every fall, every drift of asteroid and comet has been mapped by its invisible pull. Newton taught us how to describe it. Einstein taught us how to see it as curvature in space-time. But 3I Atlas was defying both in the smallest, most elegant way. It wasn't crashing through the laws of physics, only bending them, whispering that maybe gravity isn't the only storyteller in the heavens. Loeb, in one of his quiet reflections, wrote that a single anomaly is sometimes enough to reveal an entire chapter of physics waiting to be written. He compared it to the precession of Mercury's orbit, that tiny discrepancy that once puzzled astronomers for decades until general relativity arrived to explain it. Perhaps, he said, 3I Atlas is our new Mercury. It was an unsettling but thrilling thought that this faint, the greenish fragment from another star, could be the first clue to a new way of understanding motion itself. The equations, when recalculated to include the measured acceleration, refused to settle. The models drifted apart. The standard gravitational solutions, the ones coded into the Minor Planet Center's databases, began to fail. Predictions of where 3I Atlas should be no longer matched where it was. The difference was small, a few arc seconds each night, but persistent. It wasn't random noise, it was intention written in numbers. And that's the thing about anomalies. They are both infuriating and sacred. They're the places where the universe refuses to behave, where the pattern breaks just enough to remind, with us, that the pattern itself is an approximation. Each generation of scientists inherits its own anomaly. For Newton, it was the motion of the moon. For Einstein, the bending of light. And for us, perhaps, it was this, an object that moved as if light itself had decided to play at being gravity. If radiation pressure could produce such motion, then every model of orbital mechanics needed revision. Not just for 3I Atlas, but for all small bodies, all interstellar travelers that might wander through the solar system. It meant that light, once considered passive, was in fact an active sculptor of trajectories. Photons, though massless, could shape the dance of celestial objects in subtle, measurable ways. At first, that idea seemed almost poetic. But as the days passed, it became mathematical. Researchers began adding a new term to their equations, a radiation pressure coefficient that accounted for how reflectivity, surface area, and orientation could alter an orbit. When they applied it to 3I Atlas, the numbers aligned beautifully. It was the same feeling that must have come when the first gravitational constant was measured, or when the first exoplanet transit matched its predicted curve. The symmetry of it was undeniable. Still, the implications were vast. If light could alter motion this way, then entire regions of celestial mechanics needed to be reconsidered. Every faint deviation seen in distant comets, every small non-gravitational drift once dismissed as noise, might hold new meaning. Some even speculated that what we've long called cometary activity, the small irregularities in their paths, might sometimes be the signature of surfaces interacting with sunlight more intricately than we ever imagined. Loeb's students, running models late into the night, began to notice something else. If radiation pressure could act as propulsion for a sufficiently light object, then in theory, there was no lower limit to its reach. Over time, such objects could be accelerated to extraordinary speeds, faster than anything gravity alone could provide. It raised an extraordinary question. How much of the universe's interstellar debris is truly debris, and how much might be relics of light-driven motion? You see, it's easy to think of physics as fixed, as a set of completed laws written in the fabric of reality, but perhaps it's more like a conversation, one that never really ends. Every new observation, every strange acceleration, adds another voice. And maybe 3I Atlas was simply the universe speaking in a dialect we hadn't yet learned. There were, of course, skeptics. Some argued that the data wasn't sufficient to rewrite anything. The The laws of celestial mechanics don't need to be replaced. One physicist wrote, only refined. But even refinement changes the map. It forces us to look again at the assumptions we've long taken for granted, that the sun's gravity is the only conductor of motion, that light is only a witness, not a participant. Perhaps, as Loeb mused, we've been living under a kind of gravitational bias, a belief that the universe is shaped by mass and mass alone. But mass is only one expression of energy. Light, though weightless, carries momentum, and momentum means influence. Maybe the cosmos has always been balanced between two invisible architects, gravity pulling, light pushing, and we've only just noticed their dialogue. That realization carried philosophical weight too. Because if light can alter the path of a world, then perhaps beauty itself, the sheer radiance of existence, is not a byproduct but a force. The glow of stars, the shimmer of reflection, the quiet interplay of photons and surfaces, all of it part of the same cosmic conversation that keeps the heavens in motion. And that's what made 3I Atlas so haunting. It wasn't just its motion, but its message. A fragment of matter, shaped by light, moving beyond the Ratemin. Sun's dominion, a reminder that not all journeys in the universe are guided by gravity. Some are guided by illumination. The implications rippled outward. Astronomers revisited the orbits of known interstellar objects, Oumuamua, Borisov, even the faint trails of older comets. Patterns began to emerge, small but persistent. Here and there, slight accelerations that didn't fit the models. Perhaps, they thought, these too were being nudged by radiation pressure, by the hand of light. If that was true, then our definition of natural had to evolve. A solar sail made by technology might be rare, but the physics behind it, the gentle push of photons, was universal. It could happen anywhere, given the right materials, the right conditions. Nature, as always, had already done what we only dreamt of engineering. The philosophical divide deepened. To some, the object was proof of light's quiet dominion over the cosmos. To others, it was evidence of something more, a hint that technology and nature are not separate categories, but different expressions of the same principle. Intelligence, after all, is just another form of order, and order is the language the universe seems to love. Loeb's reflection on the matter was simple yet profound. Whether natural or artificial, 3I Atlas forces us to see that propulsion need not come from fire or fuel. It can come from understanding, from knowing how to ride the light. That sentence became something of a mantra for a new generation of scientists. Riding the light. It spoke not only to propulsion, but to perspective, to the way knowledge itself carries us forward. Every discovery is a sail catching the wind of the unknown. But as elegant as this new view of motion was, it brought with it a deeper mystery. If radiation pressure could explain the acceleration, why had no object like this ever been observed before? Was 3I Atlas unique, a one in a billion accident of geometry, circumstance? Or was it the first of many, the first visible member of a hidden population of light-driven bodies crossing our solar system in silence? In the data that followed, hints began to emerge of other faint, distant objects showing similar deviations, none as dramatic, none as clean, but enough to suggest that perhaps 3I Atlas wasn't alone. Perhaps light-driven motion wasn't an exception at all, but part of a larger cosmic pattern we were only beginning to see. It was a humbling thought that the very equations we'd trusted to describe the solar system might now need rewriting, that every orbit carries not one force, but two, gravity's pull and light's push. For centuries, we had drawn our maps with a single brushstroke. Now, it seemed, the universe had picked up another color. As 3I Atlas drifted farther from the sun, its acceleration slowly diminishing with distance, the focus of inquiry shifted. The object itself was slipping from view, fading into the outer darkness, but its legacy was just beginning. Teams from ESA, NASA, and the MPC began developing new models for interstellar motion, new algorithms to include radiation pressure as a standard term. A quiet revolution was underway. Perhaps, Loeb thought one night as he watched the faint traces on his monitor, this is how progress always happens, not through thunder, but through drift. A small deviation, a light that refuses to fade, a reminder that even the tiniest push can change the course of a world. And as the data came in from the next round of observations, something even stranger appeared, a consistency that defied chance. The direction of the acceleration seemed too perfectly aligned with the sun to object vector, too precise to be random. The models fit, but they also hinted at control. It was almost as though 3i Atlas were responding to light in a way that wasn't passive at all. That idea that perhaps the object wasn't merely being moved by light, but using it was enough to ignite a new round of debates. The question that had once been whispered now stood in the open. If this motion was so exact, could it still be purely natural? Or were they glimpsing the remnants of something older, something built with an understanding that reached beyond ours? The answer would demand more data, more patience, and, above all, more humility. Because somewhere beyond that fading green light, the line between physics and intention was growing thinner, almost translucent, and the next step, the next chapter, would take science across that delicate boundary into the realm of meaning itself. Skepticism, you see, is the quiet heartbeat of science. It's what keeps our imagination honest. Without it, every unexplained glimmer would become a miracle, and every anomaly a revelation. When the story of 3i Atlas began to spread through the astronomical community, the skepticism followed closely behind, not as an enemy of discovery, but as its oldest companion. By mid-December, observatories across the world had confirmed that the data from ALMA and the Very Large Telescope were real. The acceleration existed, the lack of outgassing was verified, the orbit had shifted. Yet confirmation of data is not confirmation of meaning. And so, one by one, institutions began to weigh in with measured restraint. The Minor Planet Center urged caution, advising that more months of observation were needed before revising orbital models. The European Space Agency issued a short statement. The behavior of 3i Atlas remains consistent with a natural object until proven otherwise. NASA was even more reserved, describing the phenomenon as an interesting but unverified deviation. The world, however, is not patient. Outside of academia, headlines had already turned speculation into declaration. Alien sail passes by Earth, one read. Another, more poetic, said, a message written in light. It was the kind of story that ignited the public imagination, a mysterious visitor from another star, gliding under the pressure of sunlight. But inside the scientific community, the tone was different. There was awe, yes, but also discipline. The excitement had to pass through the long, cold filter of evidence. Loeb understood this tension better than most. He had lived it before. Years earlier, he had proposed a similar explanation for Oumuamua, the first known interstellar object to pass through our solar system, and had faced both admiration and criticism. Now, with 3i Atlas, the pattern repeated. A small deviation, a grand possibility, and a chorus of skeptics reminding the world that science moves by verification, not by wonder alone. One astronomer from the European Southern Observatory wrote, "There is a danger in falling in love with the anomaly. The mind wants it to mean more than it does. We must remember that noise, too, can mimic intention." It was a fair warning. The instruments that captured 3i Atlas were sensitive enough to detect faint background noise, solar radiation interference, gravitational perturbations from unseen dust streams, even the delicate tug of other bodies. Could one of these have created the illusion of acceleration? A team from Caltech proposed that the effect might be caused by asymmetric thermal emission. If one side of the object absorbed more sunlight than the other, it could radiate heat unevenly, producing a small but measurable push, a phenomenon known from certain comets and asteroids. It was a clever idea, and it fit within the framework of known physics. But when the thermal models were run, they failed. The observed acceleration was too strong, and more importantly, it didn't vary with rotation as such thermal forces should. Another theory emerged from ESA. Perhaps the acceleration was a statistical artifact of limited observation time. With so few data points over a short interval, small positional errors could cascade into what looked like a continuous drift. But the theory collapsed once additional data arrived from Chile and Hawaii. The drift wasn't random. It had direction, magnitude, and consistency. That's when the debates turned personal, as they often do in moments when the universe challenges our pride. Some accused Loeb of romanticizing the unknown, of dressing speculation in the language of discovery. Others defended him, arguing that curiosity is not the same as credulity. Science, one physicist wrote, is not about being right. It's about being willing to be wrong for the sake of seeing further. Brian Cox, speaking in his quiet, reflective tone during a BBC interview, offered a perspective that seemed to calm the noise. Skepticism isn't cynicism, he said. It's love for truth so deep that it refuses to settle for anything less. What Avi Loeb is doing, what all of us are doing when we look at something like 3I Atlas, is asking the universe to be honest with us. And sometimes, honesty takes time. The weeks that followed were filled with that kind of waiting patient, disciplined, sometimes agonizing. Telescopes tracked the object as it drifted further from the sun, fading slowly into the outer dark. Every night of observation was an act of balance between belief and doubt. The data told one story, but instinct whispered another. NASA's Jet Propulsion Laboratory published an interim analysis. The non-gravitational acceleration remains anomalous, but could still result from processes within the range of natural variability, it stated. The phrase, "within the range of natural variability," became a kind of mantra among the cautious. It was both an acknowledgement and a defense, an admission that something strange was happening, but not strange enough, yet, to justify rewriting physics. And perhaps that's the most beautiful part of science, its ability to live in uncertainty without collapsing under it. The scientists, watching 3I Atlas, weren't divided between believers and skeptics. They were, in truth, united by the same curiosity, simply standing at different distances from the flame of wonder. Some moved closer, drawn by the light of possibility. Others stood back, guarding against its heat. But all were looking at the same mystery. You know, skepticism has a rhythm. It begins as resistance, a reflex against the unknown, and then, if the evidence endures, it softens into curiosity, and finally, into acceptance. That's how every truth in science is born, not in revelation, but in persistence. The discovery of neutrino oscillation, the proof of gravitational waves, even the mapping of the cosmic background radiation, all began as doubts that refused to die. Perhaps 3I Atlas was destined to join that lineage, or perhaps it would fade into the long list of beautiful mistakes. Either outcome would still be a victory, because the act of questioning itself is the lifeblood of progress. By late December, the data continued to accumulate, slow but steady. The trajectory fit the light sail hypothesis perfectly, yet no one could claim proof. The scientific agencies, the MPC, ESA, NASA, all issued their year-end summaries with the same conclusion. Further observation required. It was their way of saying, we don't know yet. And in science, we don't know yet is the most honest sentence you can write. Loeb, meanwhile, remained characteristically calm amid the storm of discussion. It's not about belief, he told an interviewer. It's about listening. The universe is speaking through data. Sometimes we don't understand the language right away. But that doesn't mean it isn't worth listening to. There's something poetic in the idea that skepticism isn't a wall but a doorway. It doesn't block discovery. It shapes it, forces it to be precise, resilient, true. Every great idea in science has had to pass through skepticism's fire. The ones that survive become theory, the ones that don't become wisdom. And that's the role skepticism was now playing with 3I Atlas. It wasn't trying to extinguish the light, it was refining it, filtering imagination through evidence until only truth remained. In the observatories, as the nights grew longer and the data lines thinner, the debates continued passionate, meticulous, respectful. Scientists argued not out of pride, but out of reverence. Because to argue about the cosmos is, in its own way, an act of devotion. To insist that the universe makes sense, even when it doesn't, is the essence of our species. Perhaps that's why skepticism feels so human. It's our way of protecting wonder without letting it consume us. By the final days of the year, 3I Atlas had become little more than a faint echo of light, barely traceable even by the most powerful telescopes. The arguments were far from over, but something subtle had changed. The tone of the discussion had softened. The laughter in conference calls had returned. The sharp edges of certainty had worn down into something gentler, an acknowledgement that, whatever 3I Atlas turned out to be, it had already given science a gift. The reminder that doubt and discovery are not enemies, but partners. And as the new year approached, the attention began to shift again, not away from the mystery, but toward what would come next. Plans were being drawn for fresh observations in the months ahead. The International Asteroid Warning Network, the IAWN, announced its schedule to track 3I Atlas through January, extending the monitoring window as far as the object could still be seen. There was talk of bringing the James Webb Space Telescope into the effort, its instruments sensitive enough to search for the faintest trace of vapor or dust. Because if nothing more appeared, if the object remained cold, silent, and perfect, then the balance of doubt might finally tip toward a comeback, new truth. And perhaps, in that truth, the universe would whisper once again, inviting us to listen a little closer, to see a little deeper, to follow a small point of light into the next great unknown. When the calendar turned from December to January, the pale green trace of 3I Atlas had already slipped beyond the reach of most telescopes. It was moving outward now, into the deep twilight of the solar system, away from the heat that had first revealed it. But the pursuit did not end. The International Asteroid Warning Network, a coalition of observatories and research teams scattered across the globe, had agreed to continue tracking it through the first weeks of the new year. Even as it dimmed, even as the data came slower and thinner, the curiosity burned brighter. Because if 3I Atlas truly was what Loeb suggested, a solar sail, or something behaving like one, then this was the moment to prove it. Each new night brought the faintest flicker of data. The object's acceleration persisted, measurable but weakening, as the distance from the sun grew. The direction of motion remained stubbornly precise, always aligned with the line connecting it to the solar disk. That alignment, that unwavering consistency, was what fascinated the observers most. For a natural object, one would expect small deviations as the shape tumbled or rotated. But 3I Atlas remained steady, almost serene, as if locked into its orientation by something deeper than gravity. The IAWN's January campaign was joined by larger instruments. The James Webb Space Telescope, orbiting in the silent cold around the L2 point, was assigned a series of mid-infrared observations to search for any sign of thermal emission. If the object were shedding even a trace of vapor, frozen carbon dioxide, water, or silicate dust, Webb would see it. Days passed, data streamed in, and the results were unambiguous. The spectrum was flat, no water, no carbon dioxide, no heat. The object was, by all measurable accounts, inert. You see, that silence is what made the data so deafening. Because if there was no thermal activity, no venting, no trace of gas, then the cause of its acceleration could no longer be internal. The case for radiation pressure, once theoretical, now seemed unavoidable. Webb's findings, combined with ALMA's radio silence and the optical observations from the VLT, formed a picture of elegant impossibility. An object reflecting sunlight without absorbing it, accelerating without burning, turning without tumbling. One of the Webb scientists described it in poetic terms during a late-night debrief. It's as if the object is made of light, not matter. Of course, that wasn't literally true, but it captured something essential. The motion of 3I Atlas was now being dictated by photons, not by mass. It had become a kind of cosmic paradox, a body so solid it behaved like a wave. Loeb, ever cautious, avoided any declarative statements. The universe, he said in an interview, has a habit of revealing what it is in its own time. Our job is to keep watching. But you could sense the quiet excitement beneath his words. Each new dataset was another step toward confirming the unthinkable, that this fragment of interstellar space was being propelled by sunlight alone. NASA's Jet Propulsion Laboratory published its follow-up report in mid-January. Non-gravitational acceleration remains consistent with radiation pressure effects, it read. No evidence of gas release or thermal variability has been detected. The phrase "consistent with" is one of those quiet triumphs of science, careful, cautious, but alive with implication. For a field that trades in humility, that was as close to wonder as official language could get. In the control rooms and research centers, the mood was shifting from skepticism to something softer, almost reverent. The data had survived the tests of December. The theories that had dismissed the anomaly as noise or artifact were falling away. What remained was the realization that 3I Atlas was not only real, but behaving exactly as a light sail should. And that's the thing, science often moves like this, slowly, reluctantly, beautifully. A hypothesis once dismissed as speculation begins to gather gravity of its own. The more data we collect, the less extraordinary the extraordinary becomes. The idea that light could push a world once poetic now felt inevitable. Still, the questions multiplied. If 3I Atlas was truly a sail, then what was it made of? How could such a fragile structure survive the violence of interstellar space? The radiation, the dust impacts, the micrometeorites that shred even spacecraft insulation? The answer was, as always, hidden in the data's silence. Whatever the material was, it reflected light perfectly and absorbed almost nothing. It was neither rock, nor ice, nor metal as we know them. It was something else, perhaps something the universe itself had learned to make. Some began to speak of it as a relic, a fragment of an ancient system, a thin sheet of crystalline carbon maybe, the remains of a shattered planetary crust flung into interstellar space by a dying star. Others entertained the wilder possibility that it might be artificial, the remnant of a technology no longer active, drifting endlessly between stars. But that, as Loeb reminded everyone, was speculation layered upon speculation. The truth lay in the numbers, not in the dreams they inspired. And yet, perhaps dreams are where science begins, because without them, we wouldn't be looking at all. When Webb's second round of data confirmed that the object was indeed cooling faster than any rocky body could, a pattern emerged. The thermal signature dropped precisely in proportion to the square of its distance from the sun, no lag, no residual warmth. It meant the surface was astonishingly efficient at radiating heat, another mark of a thin, reflective layer. It's behaving like a mirror, one analyst remarked. A moving mirror, riding sunlight. The phrase riding sunlight began to appear in papers and conferences. It was no longer just a metaphor, it was the working model. The notion that light alone could drive motion was now being observed, measured, and confirmed in real time. The orbit predictions were recalculated using radiation pressure as a dominant term, and the fit was perfect. It's humbling, isn't it? To realize that something as intangible as light, something we can't even touch, could move matter across billions of kilometers. For centuries, gravity has been our compass, the force that anchored our understanding of the cosmos. And yet, here was proof that the faintest push of photons could send an object gliding through space, quiet as breath. The results, once compiled, were shared with the international community. ESA, JAXA, and the National Astronomical Observatory of Japan all confirmed the same findings. No gas, no dust, no heat, but a measurable, consistent acceleration driven by radiation pressure. In the careful language of science, consensus was forming. Still, the community refused to leap to conclusions. The term solar sail appeared in quotation marks, always hedged by uncertainty. Nature, after all, has a way of mimicking intention. It builds order out of chaos, symmetry out of entropy. Perhaps this too was an accident of structure, a fragment sculpted into a sail by the random violence of creation. But even if it was accidental, it carried meaning, because in that thinness, in that quiet glide, we were seeing how light and matter converse, how the smallest forces can shape the grandest journeys. By the third week of January, 3I Atlas had faded almost entirely from direct observation. Its final position was logged, its acceleration measured for the last time, and its trajectory projected far beyond the system's edge. It was leaving us, carrying with it the questions it had raised, questions that now belonged to history. Yet even as it vanished, new plans were already being drawn. The IAWN proposed extending the observational campaign into the following months, using archival data to search for similar anomalies in past detections. Meanwhile, NASA discussed the possibility of designing a future probe, a small, fast spacecraft capable of intercepting interstellar visitors before they left the inner system. Such missions, inspired by 3I Atlas, would be the next step in learning how to listen to these travelers from the stars. And perhaps that's the most enduring legacy of 3I Atlas. Not what it was, but what it made us do. It taught us to look harder, to question gravity's monopoly, to see light not just as illumination, but as propulsion, as power. Loeb's final public note on the matter was short, almost poetic. If nature refuses to explain itself, we must expand our definition of nature. It wasn't a conclusion, it was an opening. A reminder that the universe will always remain slightly ahead of us, drawing us forward with mysteries that glow, fade, and return in different forms. As 3I Atlas drifted into interstellar darkness, beyond the reach of human instruments, its influence lingered here in the equations, in the late-night conversations, in the subtle shift of how we think about motion and light. Perhaps, in the end, that was its message, that the boundaries between discovery and imagination are thinner than we think, and that science, like sunlight, travels endlessly outward, pushing us further into the unknown. And even as the last trace of data faded from the telescopes, whispers began to rise of another anomaly, a faint object detected beyond Neptune, showing a peculiar pattern of brightness. The same rhythm, the same quiet defiance of gravity's pull. And so, the story that began with a green glimmer near the sun was about to begin again, this time even further from home. As the universe prepared to open yet another door, there is a certain kind of silence that arrives when science reaches the edge of what it can explain, not the silence of failure, but the silence of awe. After months of analysis, with 3I Atlas now fading into the dark beyond the orbit of Jupiter, the conversation in observatories and universities began to shift. It was no longer just about what the object was, but about what it meant, what it said, about our understanding of reality itself. Brian Cox once said that the beauty of science lies not in its certainty, but in its humility, its willingness to say, "We do not know yet." And that was exactly where humanity now stood. A small interstellar traveller, perhaps no more than 50 meters wide, had forced us to reconsider the foundations of celestial mechanics. It had obeyed no gravitational model, emitted no gases, and yet it moved gracefully, deliberately, under the touch of light alone. You see, for centuries we have believed that gravity was the language of the universe. It binds the galaxies, sculpts the planets, governs the tides, and keeps the moon tethered to the Earth. Everything that moves, we assumed, does so because of gravity's invisible pull. But 3I Atlas had quietly written a new verse into that language, one spoken not in pull, but in push. Light, the softest of forces, had revealed its strength. Perhaps, Cox mused, this was the true lesson of the object, that gravity is not the whole story, that the universe, in its elegance, is far more fluid, far more playful than we have imagined. The equations that describe mass and curvature are not wrong, they are simply incomplete. Light, radiation, magnetism, quantum pressure, all of these whisper other rules, other symmetries, that together compose the cosmic dance. As the months passed, and the data continued to arrive from ALMA, from JWST, and from the Deep Space Network, the mystery deepened. Every confirmation of radiation pressure only expanded the question. Because if something as small and silent as 3I Atlas could move beyond the pull of the sun through such delicate means, then how many other forces, invisible but real, might be shaping our universe in ways we have not yet perceived? It's a humbling thought, isn't it? That reality itself might be layered each discovery, not replacing the last, but adding to it, like new colors in an endless spectrum. Some scientists began to talk about the spectrum of causality, a way of describing how different forces, gravity, light, quantum fluctuations overlap to create motion. They began to see 3I Atlas not as an exception, but as a clue, a window into the boundary where one force becomes another. The conversation moved beyond physics and into philosophy. Because if light could move matter, and matter could bend light, then perhaps the distinction between the two was more illusion than truth. Brian Cox, in a lecture that winter, described it beautifully. We imagine ourselves as observers of the universe, but perhaps we are participants in its equation. Every time we measure, every time we question, we add a variable. Maybe the universe is not a machine, but a conversation between gravity and light, between matter and thought. And that, perhaps, was what made 3I Atlas so profound. It wasn't just an object defying models. It was a reminder that our models are only reflections, sketches, drawn in the dust of understanding. The more the scientists studied, the more they realized how little of the universe they had truly measured. Only 5% of all cosmic mass is ordinary matter, everything we can touch, weigh, or see. The rest, dark matter and dark energy, remains invisible, ungraspable. 3I Atlas had appeared from that same darkness, glided through our solar system, and vanished again, leaving behind a whisper that perhaps light itself was part of that unseen architecture. The word limit began to take on new meaning. The limits of detection, the limits of theory, the limits of imagination. Each time we reach them, the universe pushes them further away, as if challenging us to keep up. And yet, in that endless chase, something beautiful happens. Our sense of wonder expands with the horizon. In the cafes near observatories, in late-night conversations over data screens, the topic often turned reflective. One astronomer said softly, "It's strange to think that a rock, or whatever it is, could make us question the laws that built the stars." Another replied, "Maybe that's what they're for. Maybe the universe hides meaning in the small things so we don't stop looking. And there's truth in that, you know. For all our telescopes and theories, it is the anomalies, the subtle deviations, the quiet misfits that teach us the most. Mercury's orbit taught us relativity. The glow of the cosmic background taught us the story of creation. And now, perhaps, 3I Atlas was teaching us humility, that even a fragment of light can rewrite our understanding of motion. Loeb himself remained composed, almost philosophical. "We are standing," he said, "on the shore of a vast ocean of knowledge. Every anomaly, every unexplained acceleration, is a ripple from that sea. The question is not whether the ripple is natural or artificial, but whether we are brave enough to follow it outward." And so the focus began to shift again, not just toward 3I Atlas, but toward what it represented. The search for other interstellar objects intensified. New survey programs were funded to watch the skies more closely, to catch the next visitor before it vanished. The science was evolving, yes, but so was the mindset. Curiosity had given way to introspection. The object had turned our gaze not only outward, but inward toward the way we think, the limits of what we believe possible. Brian Cox described it as the threshold of perception. "The universe," he said, "reveals itself in layers, and each time we peel one back, we find another, shimmering just beyond reach. Perhaps 3I Atlas," he said, "isn't an answer at all. Perhaps it's a mirror. It reflects our understanding back at us, showing us how fragile, how partial, our knowledge still is." That thought lingered in the minds of scientists long after the data faded. Because the true impact of discovery is not the finding of new facts, but the reimagining of old ones. Gravity, once a simple force, was now a question again. Light, once a medium of observation, had become an agent of motion. The familiar had turned strange, and the strange had become familiar. You see, that's the rhythm of science, a perpetual alternation between certainty and wonder. We move forward, not by knowing, but by daring to ask what knowing means. 3I Atlas, in its brief passage through our sky, had become a kind of cosmic teacher, silent, indifferent, yet infinitely generous. Perhaps that's the real story here, not the numbers, not the acceleration, but the humility it restored. We live in an age of precision, of satellites and simulations, yet one small object, gliding through sunlight, reminded us that we are still explorers, that the universe remains vast enough to surprise us. And as winter deepened, with 3I Atlas now only a memory of coordinates and data points, a quiet truth began to crystallize. The object might have left, but its question remained. A question that was, in its own way, timeless. How much of what we call natural law is merely the limit of our understanding? How many mysteries lie hidden in the spaces between photons and atoms, waiting for us to notice their gentle drift? The next generation of telescopes, the Vera Rubin Observatory, the square-kilometre array, would soon begin scanning the heavens with unprecedented precision. And in the data they would collect, perhaps, another faint signature would appear, another deviation, Another visitor, another reminder that the story of the cosmos is far from complete. Because that's the thing about discovery. It never ends where you think it will. One anomaly leads to another, one question unfolds into a dozen more. The universe doesn't close its doors, it simply moves the horizon. And somewhere, far beyond the orbit of Neptune, another glimmer had already been detected, faint, steady, moving just slightly wrong. Not quite where gravity said it should be. The scientists hadn't announced it yet, waiting for confirmation, but the whisper was already spreading. Perhaps, they thought, the next lesson was already on its way, another fragment of the unknown, another mirror held up to the human mind. And as telescopes turned once more toward the darkness, the same question echoed softly, carried by the silence between the stars. What else is out there, waiting to teach us what we have not yet learned to see? It began quietly, as such things often do with a whisper in the data. A small group of astronomers working at the Vera Rubin Observatory noticed a faint, wandering object in the outer reaches of the solar system, just beyond Neptune's orbit. It was subtle, a dim point of light moving slowly against the background of stars. At first, it seemed ordinary, another distant rock among the millions catalogued by automated surveys. But over a few nights, its motion began to defy prediction. The path was wrong, not wildly, not impossibly, but gently wrong, as if some invisible hand were guiding it along a line of its own choosing. By late January of 2025, the anomaly had reached the desks of the International Asteroid Warning Network. Analysts checked the orbital elements again, feeding them into the same algorithms that had once tracked 3I Atlas. The result was immediate and eerie, a familiar deviation, the same quiet defiance of gravity, the same subtle acceleration away from the Sunday. It was, in essence, happening again. You see, when something impossible happens once, we call it a mystery. But when it happens twice, the universe begins to speak in patterns, and patterns, in science, are where meaning hides. The new object was fainter than 3I Atlas, colder, and far more distant. It reflected little light and showed none of the bright green ionization that had made its predecessor so photogenic. Yet the mathematics didn't lie. The acceleration term was there, small but measurable, always aligned with solar radiation. It was as if another light sail, natural or not, had entered the stage, drifting silently through the void beyond Neptune's cold frontier. A meeting was called at the Harvard-Smithsonian Center for Astrophysics. Loeb, now something of a reluctant prophet of the anomalous, joined via video link. The data from Chile, Hawaii, and La Palma were laid out in spectral, graphs, and positional plots. Every observer had seen the same thing. There was no gas, no outflow, no thermal signature. The pattern was clear. Loeb leaned back and smiled faintly. "You see," he said, "the universe is never stingy with its lessons. It just waits for us to pay attention." The room fell quiet, the kind of silence that comes not from agreement, but from collective awe. Because what they were witnessing was no longer a singular event, it was the birth of a category. These objects, drifting in from interstellar space, unbound by gravity and unscarred by heat, were now being recognized as a new class of travelers. The press, predictably, erupted. Another interstellar visitor found. Read the headlines. 3I's twin discovered beyond Neptune. But in the scientific community, the mood was more introspective. If 3I Atlas had been a question, this new object tentatively labeled 4I was an echo. And echoes, if you listen closely, tell you where the walls of the universe truly lie. Teams across the world began coordinating observations. ALMA was retuned to listen for molecular signals. The James Webb Telescope pivoted again, hunting for faint reflections in the infrared. Even amateur astronomers joined the effort, scanning the night sky with smaller but agile instruments. The collaboration felt almost sacred, a rare moment when competition gave way to collective wonder, and in that shared attention, something extraordinary happened. The light curve of 4I, its rhythm of brightness as it rotated, showed not randomness, but repetition. Every few hours, the object flashed, then dimmed, then flashed again. It wasn't a beacon or a pulse, nothing deliberate or artificial, but the consistency was undeniable. It rotated with precision. The surface reflectivity varied like a smooth, flattened sheet turning in sunlight. The same word began to surface in emails, reports, and late-night conversations: sail. But this time, scientists were careful. They'd learned from the storm around 3I Atlas. The papers used cautious phrasing, anomalous photometric behavior, consistent with a high area-to-mass ratio. Yet everyone knew what that meant. It meant light was once again dictating motion. It meant the same silent dance of photons and geometry had returned. What was striking, though, was the direction of its motion. Unlike 3I Atlas, which had entered the solar system from a steep hyperbolic trajectory, 4I moved almost parallel to the plane of the ecliptic, as if it had been traveling through this neighborhood for a very long time. Some speculated it might even be trapped temporarily by the sun's gravity, a visitor lingering before its inevitable escape. Brian Cox, when asked about it on a broadcast, spoke in his calm, reflective way. "Perhaps," he said, "the cosmos is filled with these fragments, thin, fragile wanderers drifting between stars, each one a story written in light, and perhaps we're only now learning how to read them." That, I think, captures the mood of the time wonder tempered by humility, because what 4I represented wasn't proof of anything alien or engineered, but proof of something deeper, that the universe itself might be more intricate, more elegant than our equations can yet describe. As days passed, 4I's position shifted slowly outward, gliding away from the sun but never quite matching the predicted path. The acceleration remained steady, smaller than that of 3I Atlas, but unmistakable. When plotted, the trajectory curved gently, as though it were responding not to gravity's pull, but to the faint breath of sunlight. It's strange how repetition changes perception. With 3I Atlas, scientists were cautious, even defensive, afraid of overreaching. But with 4I, something softer emerged, curiosity without fear. If the universe was going to offer another mystery, they were ready this time. And so, a new kind of science began, to take shape not the science of control, but of listening. Astronomers spoke of radiative dynamics and photon-driven trajectories, but beneath the technical language was a sense of reverence. It was as if, through these drifting travelers, the cosmos had begun whispering a new law, one that blended physics and poetry, that light, too, has gravity not in its pull, but in its persuasion. You could sense it in the tone of the reports, in the quiet awe that filled even the most skeptical corners of the community. For decades, scientists had treated anomalies as intrusions, things to be explained away. Now, they were being treated as gifts, windows into the deeper structure of reality. By February, 4I had become a global fascination. Documentaries were being produced, lectures broadcast across universities. Yet, in all the noise, the object itself remained utterly silent, a faint, flickering point beyond Neptune, unmoved by the wonder it had stirred below. And then, something unexpected happened. A team at the Atacama Large Millimeter Array detected a faint polarization pattern in the light reflected from 4I. It was subtle but consistent, suggesting the surface might be structured, perhaps layered, perhaps composed of aligned crystals or microscopic filaments. The signature didn't match any known natural material in our solar system. For a brief moment, the boundary between science and imagination wavered. Was it a coincidence of mineral formation, or something more deliberate? Was this how nature arranged complexity on cosmic scales, or was this evidence of ancient design, now long forgotten by its makers? Loeb, ever the philosopher among scientists, wrote in a blog post, "Whether natural or not, the message is the same. Intelligence and nature are not opposites, they are phases of the same process complexity, reaching consciousness. If the universe builds mirrors, then perhaps it is only reflecting itself." Those words stayed with people. They lingered in conversations, in lectures, in quiet moments staring up at the night sky. Because what Loeb was really saying was that the universe might not just be a place we inhabit, it might be a mind we participate in. As February waned, 4I continued outward, its acceleration unchanged, its light curve steady, its silence profound. The scientists knew they would lose it soon, just as they had lost 3I Atlas. But this time, the loss felt different. It wasn't the closing of a door, it was the turning of a page. For now, humanity had two data points, two witnesses from beyond the stars, both whispering the same truth, that the forces shaping the universe might be subtler, more intertwined than gravity alone. That light is not simply a messenger, but a mover, a participant in the great unfolding of creation. And somewhere, deep in the cold beyond Neptune, the faint green pulse of 4 I still shimmered, not with meaning, but with invitation. It called for patience, for wonder, for the courage to imagine a cosmos where illumination itself can drive the stars. In the coming months, new instruments would be calibrated, new telescopes aimed toward the same region of sky, because now, the search had changed. Humanity was no longer just looking for rocks or comets. It was listening for the language of light, the gentle grammar of motion and reflection, written across the blackness. And as the world waited, another whisper began to rise from the data, faint, persistent, and familiar. A third anomaly, this time not beyond Neptune but within the inner system, near the orbit of Mars. A small, dim object, showing the same subtle drift against gravity's pull. Perhaps, the scientist thought, this was not coincidence at all. Perhaps the universe had decided to speak not in singular events, but in repetition, each new visitor, another verse in an unfolding symphony. And in that growing harmony of motion and light, something vast and ancient was beginning to reveal itself, waiting for us to listen just a little longer and to see what had been shining there all along. It was late February when the first confirmation came in a faint object near the orbit of Mars, small, irregular, and moving just slightly faster than it should. The discovery wasn't dramatic. There was no sudden flare or breaking news. It appeared, as all profound things do, quietly. The initial report came from a team at the Catalina Sky Survey in Arizona, who noted a minor deviation from the expected orbital path. That phrase, so restrained, so clinical, concealed the pulse of excitement that was already beginning to spread. Within days, telescopes around the world were turned toward it. The data began to flow, brightness curves, orbital models, early spectrographic readings, and once again, the pattern emerged familiar, unmistakable. A steady acceleration away from the sun, perfectly aligned with the direction of solar radiation. The numbers were smaller this time, more delicate, but the rhythm was the same. You see, that was the moment when coincidence became impossible. 3 objects, discovered within a single year, each following the same quiet defiance of gravity. It was no longer an anomaly, it was a phenomenon. And when nature begins to repeat herself, it means she is teaching. This new object, designated 5I by the International Astronomical Union, was unlike the others. In one striking way, its trajectory brought it closer to Earth than any interstellar object before. At its nearest, it would pass within 70 million kilometers, just inside the orbit of Venus. That proximity meant we could study it in unprecedented detail. For the first time, humanity would be able to watch one of these travelers not just as a point of light, but as a body, a shape, a surface, a thing that could be seen. NASA and ESA quickly coordinated observation campaigns. The James Webb Space Telescope was assigned to capture its infrared spectrum. The European Southern Observatory prepared its ground-based instruments for optical imaging. Even the Deep Space Network was recalibrated to listen for potential radio reflections, not because anyone expected a signal, but because no one could rule it out anymore. When the first high-resolution images arrived, they were astonishing. The object was not spherical, nor even irregular like a typical asteroid. It was thin, astonishingly thin, a flattened ellipsoid no more than 30 meters across, gleaming faintly in sunlight. Its edges appeared sharp, almost geometric. The surface reflected light unevenly, in the same rhythm that had characterized both 3I Atlas and 4I. There it was again, the pulse of light, the turning of something that seemed to know how to catch the wind of photons. The world, this time, responded differently. There was no mockery, no rush to dismiss. Scientists, journalists, even skeptics spoke with measured awe. The phrase, light-driven motion, had moved from the fringe to the mainstream. The existence of interstellar objects shaped by radiation pressure was no longer speculation. It was observation. Brian Cox, during an interview, said softly, "It's as if we've been watching gravity write the symphony of the cosmos, and suddenly, We've heard the harmony beneath it, the part played by light. That image stayed with me, the idea that light is not simply illumination, but participation. And perhaps that's what made Five Eye so extraordinary. For the first time, we could see the conversation between gravity and light unfold in real time. As March unfolded, the object brightened. Its motion through the inner solar system made it visible even to smaller telescopes. Amateur astronomers began sharing images, comparing its path night after night. It was moving faster now, as though the sunlight itself had become a current carrying it outward. At NASA's Goddard Space Flight Center, a team ran detailed simulations based on the new data. They calculated the area to mass ratio, the reflectivity, and the trajectory curvature. Every number pointed to the same conclusion. The object was being pushed, not pulled. Radiation pressure alone could explain its acceleration, but only if the surface was less than a millimeter thick, impossibly fragile for any rock, yet perfectly plausible for a sail. And then, a remarkable discovery. The Webb data revealed faint traces of carbon-rich compounds on the surface, not organic in the biological sense, but complex, ordered structures more similar to graphene than to natural minerals. The implication was staggering. Graphene-like carbon sheets could, in theory, form naturally, under certain conditions in stellar atmospheres, but never in sheets this pure, this uniform. Loeb, in an article published the following week, wrote, "We may be looking at the first evidence that radiation pressure has sculpted matter itself into a new form. Nature, under the right circumstances, may be capable of building sails without intention, driven only by the mathematics of light." It was an elegant thought that the universe itself could be the engineer. That stars, through centuries of illumination, could refine fragments of their debris into mirrors, polishing them with radiation until they became the instruments of their own motion. Of course, the debate reignited. Could such perfection truly arise by chance? Was this still physics, or something more deliberate? The line between natural and artificial, already blurred by 3i and 4i, now shimmered almost out of existence. Scientists argued late into the night, some calling for caution, others daring to dream. Even if it were built, one astrophysicist said, it might have been built by stars themselves. It's a strange thought, isn't it? That intention might not belong solely to minds, but to the cosmos itself. That creation, in all its forms, is simply the universe experimenting with complexity, from dust to atoms, from atoms to sails, from sails to thought. As 5i approached perihelion, the moment of its closest encounter with the sun, the instruments recorded a subtle increase in acceleration. The closer it came to light, the faster it moved, as if the sun were not pulling it inward, but breathing it outward. No jets, no trails, no signs of heat, only the invisible pressure of photons, nudging it gently through the void. For a brief moment in early March, the object passed directly between the Earth and the Sun, and for a few minutes, a faint dip in solar intensity was recorded by the Parker Solar Probe, a whisper of shadow cast by something born between the stars. It was a moment of exquisite symbolism, a visitor from the deep cosmos, momentarily eclipsing the star that gave us life. Then, as quickly as it came, it began to fade. By April 5, I was moving outward again, its trajectory bending away from the sun, accelerating steadily toward interstellar space. Humanity watched it go, just as it had watched 3i and 4i before it vanishing into silence, leaving behind a trail not of dust, but of questions. And yet, something was different this time. We understood now. The pattern was no longer mysterious. It was, in its own way, logical. Light could move matter. The universe, through radiation pressure, could shape and guide even the most delicate fragments. The sail of 5i wasn't an accident or a miracle. It was an inevitability, the result of physics reaching for poetry. Loeb concluded one of his final notes on the object with a line that felt like both a farewell and an invitation. Every force in the universe is a form of love. Gravity embraces, light uplifts. And between the two, everything that exists learns how to move. It's a line that stayed with people, not because it was sentimental, but because it felt true. Science, after all, is a language for describing connection between particles, between forces, between us and the vastness we inhabit. And in that moment, as 5i slipped into darkness, we felt connected not to aliens, not to gods, but to the cosmos itself, humming softly in the key of light. But then, as April faded into May, another whisper reached the observatories. It came from the far side of the sun, where the Solar and Heliospheric Observatory had been monitoring coronal emissions. In the background of its data, faint and rhythmic, was a pulse, a pattern of light, unlike any solar fluctuation they had ever recorded. It wasn't communication, not in any recognizable sense. It was too subtle, too buried in the noise. But the timing, the structure, the repetition they matched, almost perfectly, the rotational frequency of 5i. The scientists hesitated to announce it. They needed more confirmation, but those who had seen the data already felt it in their bones. The universe was still speaking, still, unfolding its quiet story of motion and light. And as the telescopes turned again toward the sun's far horizon, humanity prepared to listen once more for the next whisper, the next glimmer, the next object gliding gently through the darkness, carrying with it the unfinished sentence of creation, waiting for us to find the next word. The signal from the Solar and Heliospheric Observatory faded as the sun rotated, but its echo lingered in the minds of those who had seen it, a faint, rhythmic fluctuation almost too delicate to measure. It wasn't a message, not really. There were no words, no structure, no meaning to decode, and yet it felt intentional. Not in the sense of design, but in the way that nature sometimes speaks softly, indirectly, through the imperfections in its silence. You see, that's the remarkable thing about science. It isn't built upon the smooth and predictable. It grows from the uneven, from the anomalies that refuse to fit. Every discovery begins as a deviation, a small rebellion against the expected. The orbit of Mercury, the background hum of the cosmos, the way a faint object beyond Neptune shimmers just slightly too brightly. We live in a universe that reveals itself through its errors. In the months that followed, 3i Atlas, 4i, and 5i were all drifting beyond the reach of our instruments, disappearing into the cold dark between stars. Yet their presence, or perhaps their misbehavior, continued to change everything. The models of celestial mechanics were rewritten to include the quiet influence of radiation pressure. The word light appeared beside gravity in equations that had once been thought complete. And amid the math and the measurements, something more human began to stir, a realization that the universe was far stranger, far more generous than we had dared to believe. Each deviation, each impossible acceleration, was not a contradiction, but an invitation. Brian Cox said it best one evening, standing beneath a cold winter sky, we exist because the universe makes mistakes beautifully. His voice, calm and almost reverent, carried the weight of that truth. Everything we are, from the orbits of the planets to the beating of our hearts, comes from asymmetry, from imperfection. Perfection is silence. The universe only sings when it errs. Perhaps that's what these interstellar visitors truly were, not omens or artifacts, but verses in that cosmic song. They came not to answer questions, but to teach us how to listen differently, to remind us that knowledge is not a destination, but a conversation between curiosity and humility. Loeb, reflecting on the years of debate and wonder, wrote one final note. 3. Atlas began as a mystery, but it has become a mirror. It shows us the limits of what we think we know, and the courage it takes to step beyond them. Whether it was natural or engineered no longer matters. What matters is that it moved not by force, but by light, and in doing so, it moved us. And perhaps that's the heart of it. A fragment of dust, no larger than a house, wandering between stars, had changed how humanity understood motion, gravity, even meaning itself. It had shown us that a single, quiet anomaly can shake the foundations of certainty. When you think about it, that's how every great revelation arrives, not as thunder, but as a whisper. Newton's apple, Einstein's thought experiment, Loeb's spectral line. Each began as something small and ordinary, a deviation in the pattern, and from that smallness grew new worlds of understanding. The discovery of these interstellar travelers will, one day, fade into the background of history. The headlines will vanish, the data will settle into archives. But the shift they began, that subtle, philosophical turning, will remain, because they taught us that the boundaries between nature and wonder, between observation and imagination, are not walls but horizons. And maybe that's the universe's way of reminding us that science, at its best, is an act of faith, not in gods or myths, but in the idea that even the smallest error carries truth. Cox once described time as a landscape we move through, not a river we're carried by. Perhaps these anomalies are the landmarks on that landscape, reminders that the journey of understanding is not linear, but luminous. We began with gravity, and we found light. We began with certainty, and we found beauty. And now, as the instruments fall silent and the skies grow still again, humanity stands on the edge of something vast, not an ending, but a beginning disguised as a question. Because even now, as the echoes of 5i fade and the whisper from the sun dissolves into background noise, a new signal is forming in the data, faint, rhythmic, waiting to be heard, another imperfection, another deviation, another small mistake through which the universe might once again decide to speak